let's evaluate this double integral on d, where d is the set of x, y in r squared, such that x squared plus y squared is between 1 and 16. And also we have this condition that y is greater or equal than 0. Okay, in our case here now we see that our function that depends on x and y is the square root of x squared plus y squared, and it's greater or equal than 0. Okay, therefore we can give this one some meaning as the volume of this solid or this region that we have. Okay, it's not easy to evaluate this integral using the rectangular coordinates. Therefore we can move to polar coordinates. Okay, and we will see why it's very simple here to use. Okay, and we're gonna draw our d here. So d is gonna be so y is bigger than 0, and x squared plus y squared is less than 16. That means the disk centered at 0 and have a radius 4. Okay, here 1, 2, 3, 4. Okay, I'm assuming just for the clarification. Okay, 2, 3, 4. Let's say this is our disk, because y is bigger than 0. Okay, and it's the inside. And also we have the x squared plus y squared is bigger than 1. Okay, so therefore this is the outside of the unit circle. So this is my unit circle here. Okay, having radius 1 and centered at the origin, but x squared plus y squared bigger than 1, it's the outside. So this is the outside of the unit circle, and the inside of the circle centered at 0, 0 and having radius 4. Therefore my region is this one here. Okay, so this is my d. Okay, I can transform this region to another region that I'm gonna call d prime. I'm gonna use polar coordinates. So here I'm gonna use r theta. In this case, r, remember that the polar coordinates are given by x is r cosine theta and y is r sin theta. If I square x and I square y and I add them, I get x squared plus y squared is r squared. That means r squared is between 1 and 16. Okay, this means that r, since it's positive, is between 1 and 4. That means r is between 1 and 4. This condition here, y greater than 0, so here, this one here, so r sin theta is bigger than 0. Okay, r is never 0. Okay, therefore assume that r is not 0, and we have sin theta is bigger than 0. Okay, and here we see we know from the unit circle that if we draw unit circle here, and this is my theta, the sign is here. So the sign is positive when theta is between 0. So the angle here is gonna change between 0 and pi. Okay, so here r is between 1 and 4, and theta is between 0 and pi. Okay, another thing is that this dx dy changes as using the Jacobian. It's gonna be rdrdtheta. Okay, and one more thing is that we need to change this function as well. X squared plus y squared is r squared, and taking the square root of r squared is r, since r is positive. Therefore this transformation will be like this. So here x squared plus y squared is r squared, dx dy is rdrdtheta. Okay, so my integral will be, now a theta is changing between 0 and pi, and r is changing between 1 and 4, and my function is r squared drdtheta. So the r is coming from this one here, times this r, we get r squared. We see that we have r is independent of theta, therefore I can integrate independently So you have the integral between 0 and pi d theta times the integral between 1 and 4 of r squared dr. Now I can use my knowledge about definite integrals of one variable to integrate. Here I have pi, and here I have r cubed over 3 between 1 and 4. That means pi over 3 times 4 to the power 3, 64 minus 1, that's 63. And I see that 63 divided by 3 is 21. Therefore, I have 21 pi.